Hello everyone, welcome to my channel Max Sorcerer. Now we are going to discuss problems on complex numbers. Here the first problem, to express root of minus 27 as a complex number. For this problem we follow the steps. First we rewrite the square root of the negative number. We know that root of minus 27 can be written using the property of imaginary numbers. Specifically, we can express it as root of minus 27 is equal to root of minus 1 into 27. In step 2, we separate the square root. Using the property of square roots that states root a into b is equal to root a into root b, we can separate the terms root of minus 27 is equal to root of minus 1 into root of 27. After step 2, we move to step 3. Here we substitute for root of minus 1. We know that root of minus 1 is equal to I, where I is the imaginary unit. Thus, we substitute root of minus 27 is equal to I into root 27. In first step, we simplify the root 27. Before that, we have to find the factor for 27, that is equal to 9 into 3. Therefore, root 27 is equal to root of 9 into 3, that is equal to root 9 into root 3, that is equal to 3 root 3. In step 5, we combine the results. We can combine the results from steps 3 and 4. We get root of minus 27 is equal to I into 3 root 3. Thus, we can express root of minus 27 as a complex number. That is, root of minus 27 is equal to 0 plus 3 root 3 I. Therefore, the representation of complex number of root of minus 27 is 0 plus root 3 I. This is the end of the problem. After solving the first problem, we move to the second problem, that is root of minus 16. Here we separate the negative part, that is root of minus 16 can be written as product of square root of 16 and square root of minus 1. That is, root of minus 16 is equal to root of 16 into root of minus 1. After this, we simplify the each part. The square root of 16 is 4 and the square root of minus 1 is defined as imaginary unit I. Therefore, root 16 is 4 and root of minus 1 is equal to I. After this, we combine the simplified parts. In this, we multiply the results from the previous steps to get the final answer, that is 4 into I, that is equal to 4I. This is the conclusion of this problem. Welcome to my channel Max Sorcerer. Now we are moving to problem number 3. That is, to find real and imaginary parts of the complex number root 17 by 2 plus 2 by root 70 into I. For solving this problem, we follow these steps. In step number 1, we have to identify the complex number. The given complex number is z is equal to root 17 by 2 plus I into 2 by root 70. In step 2, we recognize the standard form of a complex number. A complex number is generally in the form z is equal to a plus ib, where a is the real part and b is the imaginary part. After finishing step 2, we move to the step 3. Here we compare with the standard form. From our complex number, the real part a is root 17 by 2 and the imaginary part b is 2 by root 70. Therefore, real part is root 17 by 2 and imaginary part is 2 by root 70. This concludes the third problem. Hello everyone, welcome to my channel Max Sorcerer. Here the problem number 4. If 4x plus I into 3x minus y is equal to 3 plus I into minus 6, where x and y are real numbers, then find the values of x and y. Step 1. Formulate the equation. Step 2. Equating the real and imaginary parts. And in step 3, we solve for x and y. In formulating the equation, the given equation can be interpreted as a complex number equality. The left side has a real part and an imaginary part, and right side is a complex number with a real and imaginary part. The equation is 4x plus I into 3x minus y is equal to 3 minus 6i. In equating the real and imaginary parts, for two complex numbers to be equal, their real parts and the imaginary parts must be equal. By equating the real parts, we get 4x is equal to 3, and by equating the imaginary parts, we get 3x minus y is equal to minus 6. In step 3, we solve for x and y. From the first equation, we can solve for x, that is equal to 3 by 4. Now we substitute the value of x into the second equation to solve for y. Therefore, 3 into 3 by 4 minus y is equal to minus 6. That is equal to 9 by 4 minus y is equal to minus 6. That is equal to y is equal to 9 by 4 plus 6. Y is equal to 9 by 4 plus 24 by 4. Therefore, the values of x and y are x is equal to 3 by 4 and y is equal to 33 by 4. That's all the problem. So with this problem, I conclude this session. So if you have any doubts or clarification in this problem or in this chapter, you can put comment on the comment box. I saw the comments and rectify the same. And those who didn't watch my channel, I will put the link in my description box. You can click on the link and see the video. Hi everyone, welcome to the Max channel Max Soccer. In previous session, we are going to discuss some of the problems on complex numbers. Today also I am going to discuss some more problems on complex numbers. Here the one problem such that write the complex number 5 minus 7 root minus 21. This problem can be solved by steps. In step number 1, we simplify the radical term. The given expression is 5 minus 7 root minus 21. To write this as a complex number, first simplify the radical term root minus 21. We know that imaginary unit is defined as I is equal to root minus 1. Therefore, we can rewrite root minus 21 as root minus 21 is equal to root of minus 1 into 21, that is equal to root 1 into root 21, that is equal to I root 21. Hi, hello everyone. I am HarshaVardhan. Welcome to my channel Max Soccer. In previous session, we discussed about the 10th problem. In this, now I am going to discuss about 11th problem. Evaluate root of minus 16 plus 3 root minus 25 plus root of minus 36 minus of root minus 625. This problem can be solved by using step by step. In step 1, we simplify the each term using the imaginary unit I. The imaginary unit I is defined as root of minus 1. Then we can simplify the each term by factoring out root minus 1. Therefore, root minus 16 is equal to root 16 into root minus 1, that is equal to 4i. 3 root minus 25 is equal to 3 root 25 into root minus 1, that is equal to 3 into 5i, that is equal to 15i. Root minus 36 is equal to root 36 into root minus 1, that is equal to 6i. After that, root of minus 625 is equal to root of 625 into root minus 1, that is equal to 25i. After step 1, we move to the step 2. Here we combine the simplified terms. In this, we substitute the simplified terms and back into the original expression, that is 4i plus 15i plus 6i minus 25i. In step 3, we add and subtract the terms. Here we combine real and imaginary powers. In this, all terms are imaginary, so we just add and subtract the coefficients. That is 4 plus 15 plus 6 minus 25 into I, that is equal to 25 minus 25 into I, that is equal to 0 into I, that is equal to 0. The value of expression is 0. So I will conclude this session with this problem. If you have any doubts or clarifications in these problems or in this chapter, put a comment in the comment box. I will rectify the same. And those who didn't watch my video, I'll put the link in my description box. You click on the link and see the video.